Today, I'd like to introduce you a paper from the magazine Mutilmodal Transportation. It's called, The Taxi Sharing Practices, Matching, Routing and Pricing Methods. I hope you can learn something. Taxi sharing is becoming a trendy travel mode in an increasing number of cities. By encouraging two or more passengers to share a taxi, taxi sharing can cut down travel costs, reduce traffic emissions, and relieve traffic congestion. To promote taxi sharing, this paper first reviews the existing taxi sharing practices in cities. The entire process of taxi sharing can be broken up into the following: matching, route choice, and pricing. The current situation is revealed, as well as prospects for future developments. Building on the review, new approaches are proposed to taxi sharing: matching, route choice modeling, and pricing schemes to improve taxi sharing practices and broaden their application. Taxi sharing is normally divided into three sub-problems: matching, routing strategy, and pricing. Normally, the matching and routing strategy consider the client's matching and route choices simultaneously. There are two main types of modeling: static and dynamic. The former gathers the taxi sharing demand in advance, and then optimizes clients' matching and route choices. Many earlier studies applied the static modeling method to daily commute trip data. For example, Bimpakis et al. Used the given origin and destination preferences to carry out the matching optimization between ride-sharing clients and drivers. With the rapid development of techniques, many mobile apps allow clients to publish taxi sharing demand online. More recent studies focus on dynamic modeling, with real-time demand proposed a spatial temporal index searching algorithm to address the taxi requests posted while the taxi is running. The on-road taxi has to pick up other CLN, meaning no additional sharing clients are allowed once the trip starts. To ensure that both clients and drivers benefit from sharing a taxi, a win-win pricing scheme is essential. Equity is an important element in this win-win game, with the prominent question being how to decide the fare for each sharing passenger when their travel distances are different. Various pricing schemes have been proposed to pursue equity, taking into consideration the number of clients, travel distance, waiting time, and trip urgency. To optimize matching, pairing separate ride requests with similar spatial temporal characteristics to a jointly used taxi, and route choice, choosing the shortest sharing routes, we propose a combined model that optimizes both processes. Herein, the objective of this optimization model is to minimize the operation cost and travel cost, including the fleet size and vehicle detour distance. When one passenger shares a taxi with two passengers whose origins and destinations are different, the fare should be calculated for each section. As shown in Figure 5, suppose that passenger 1 shares a taxi with passenger 2 first, and then passenger 2 shares the same taxi with passenger 3. The total fare for passenger 1 should be the non-sharing fare in link AB, plus the sharing fare in link BC. The total fare of passenger 2 should be the sharing fare in link BC, plus the sharing fare in link CD. The total fare of passenger 3 should be the sharing fare in link CD, plus the non-sharing fare in link D. Taxi sharing can produce societal, economic, and environmental benefits by reducing the number of cars and improving the utilization of available seats. To promote taxi sharing, this paper reviews the trending literature regarding its current practices. As a result, a few recommendations were made, with the potential to further improve taxi sharing. The 3 steps that make up the taxi sharing process were reviewed, i.e., matching, routing, and pricing. Some influential factors, which affect the choices made in each step, are discussed within the respective parts. To facilitate the penetration of taxi sharing into the market, some suggestions are proposed. A pioneering model is formulated to fulfill the matching and route choice steps synchronously. The hybrid pricing method, that considers the number of passengers, travel distance, and time is more equitable and can be useful to regulate the market. A new pricing method is established to cater to the complex combination of passengers who have different origins and destinations. In general, the more passengers share a taxi, the lower the fare is per passenger, and the higher income earned by the driver. Taxi sharing is a win-win travel mode that deserves more attention in the future. Continuous efforts are needed to further improve the matching, routing, and pricing algorithms, which will ensure more appealing taxi sharing services.